This walkthrough shows a practical way to teach with the Doppler effect applet. We will orient to the controls, compare several motion cases, and finish with the extension cases near the speed of sound. Across the top, the menu gives fast starting cases. Play runs, step slows the reasoning down, reset rebuilds the scene, and the speaker icon is optional. Presets reduce setup friction. A strong lesson usually starts with stationary source, then a moving source, then a moving observer, and only later reaches the combined and supersonic cases. The four controls below are the period, the source speed, the observer speed, and the sound speed C. For clear thinking, change just one quantity at a time and keep the others fixed while you compare what happens. In the stationary baseline, the wavefront spacing stays uniform. That means the emitted frequency and the detected frequency remain the same, so this first scene becomes the reference case for every later comparison. Now choose the moving source preset. As the source travels toward the observer, wavefronts are compressed in front and stretched behind. That change in spacing is the visual reason the detected pitch becomes higher in the forward direction. Next, set a negative source speed so the source moves away instead. Here the spacing near the observer opens up, so detections arrive less often and the observed pitch drops. Students can contrast this with the previous case using only wave spacing. The next idea is a moving observer. In this case, the source can stay the same, but the observer meets the wavefronts more quickly. The pattern in space does not need to change very much for the timing at the detector to change a lot. A case where both objects move is a useful extension. When source and observer head toward each other, the compression effect becomes stronger, and students can see why the detected frequency rises even more. Turn on Emit/Detect to open the timing view. The red emission marks and green detection marks translate the picture into time intervals, so students can connect the scene in space with shorter detection gaps and a larger f'. This is where step becomes powerful. Instead of watching a full run, you can pause and advance the model a little at a time. That makes it easier to ask which wave was emitted now, and when that same wave is detected later. The period control changes how often waves are emitted. When the period becomes longer, the source produces fewer wavefronts each second, so the emitted frequency falls before any Doppler shift is even considered. The sound speed C changes how quickly the disturbance spreads. Lowering C makes the motion a larger fraction of the sound speed, so the Doppler effect looks more dramatic even if the source or observer speed is unchanged. At the sonic barrier and beyond, the applet becomes an extension lesson. Near C, the fronts pile up strongly. Above C, the source outruns some of its own wavefronts, and the picture starts to suggest shock wave or sonic boom reasoning. A strong student routine is simple. Choose a case, predict the spacing pattern, run the model, and justify the result using both the world view and the timing view. That way the applet supports observation, explanation, and evidence together.